Hello everyone. Today I'm going to tell you how to convert decimal numbers into binary numbers using the division method or the division algorithm. And the division algorithm is essentially a series of steps that we use to convert decimal numbers into binary numbers or decimal numbers into octal or hexadecimal numbers, all different base systems than the decimal system. And you might know that the decimal system is base 10, meaning that there are 10 different things that can exist in one place value row in the decimal system, being 0 to 9. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, which is 10 different numbers. So we use the division method, the division algorithm, to get there. In this video, I'm going to show you how to do that, but at the end, I'm going to show you why this actually works and why it makes sense, because a lot of people learn the algorithm and move on, but I want you to understand actually why it works and why the division makes sense. How can we divide a number continually and the remainder is the correct number converted into a different system? How does that make sense? Well, I'm going to tell you. So let's do an example. Let's choose the number 5,176. Okay, 5,176. And quickly, I'll tell you that the division method is essentially you get a decimal number and you continually divide it by the base. The base that we want is 2, which is binary. We continually divide it until we can no longer divide anymore because we're at 0. And we use the remainder as the number that we need in binary. 5,176 divided by 2 is 2,588 with no remainder. So 5,176 divided by 2 is 2,588 point nothing, 0. So our remainder is 0. This number in half, this number here has a remainder of 0. Great. Now, 2,588 divided by 2 is 1,294 with a remainder again of nothing. Let's divide this. 647 with a remainder of 0. Let's keep going. Let's divide 647 by 2. That is 323.5. So that's a remainder of 1. If you don't remember how remainders work, essentially when you're dividing something, say in half, like this example, there'll be leftover numbers that aren't integers. There'll be fractions. So 647 divided into 2 chunks is 323.5 because we need 2 equal chunks. So we can separate it out like this: 323 plus 323 plus what's left over plus 1 is 647. Okay, great. Now we've written the remainder here, which means we don't need to include it in the number anymore. So we're going to continue dividing, but not use the 0.5. So we just do 323 divided by 2, which is 161, again with a remainder of 0.5. And remember, the remainders, we're converting decimal to binary, just normal numbers like this. The remainder will be 1. Okay? Now 161 divided by 2 is 80. Okay? And that's 80.5. So that's a remainder of 1. Because, look at these two numbers. There's a 1 left over. Great? You get that? Now 80 divided by 2 is 40. Great. The remainder of 0. 40 divided by 2 is 20. The remainder of 0. 20 divided by 2 is 10. We're flying through it now. The remainder of 0. 10 divided by 2 is 5 with a remainder of 0. 5 divided by 2 is 2.5. So that's 2 with a remainder of 1. Now we're getting close to the end here. 2 divided by 2 is 1. Great. And no remainder there because 2 fits into 2 one time with no decimal point. Now 1 divided by 2, that is 0.5. So we get a 0, and the 0.5 gives us the 1. 0.5 plus 0.5 is 1. Now, this here is the most significant bit, and this is the least significant bit. I don't know if you've heard those terms before, but essentially means that we start here and we go up here. Pretty rubbish straight line. But we start here and we go up here, and that is the order of the place values of our binary number. This is the direction we write it in. So let's write this out properly. 5,176 base 10 is equal to 1, remember here, 101, followed by 4 zeros, 1, 2, 3, 4, 3 ones, and 3 zeros in base 2. So this is equivalent to this, but I don't want you, when doing this at home yourself, to say, okay, that's great, that's it. I want you to check it using a converter online, and I'll leave one in the description, and I'm going to do it right now to check myself to see if I did it correctly. So 5,176, convert. There are many websites that will convert it for you. I will give one that I use, and my answer is correct. Hooray, that's good, that's not embarrassing at least. So 5,176 in base 10 is equal to 101,000,011,111,000 in base 2. We've converted it to binary, but why does this make sense? How can we get a number and divide it, and then why is the bit after the decimal point, why does it make sense that that is the correct number? How does that even work? That's like magic. It's not magic, it's math. And I'll tell you how it works by using a quick decimal to decimal conversion answer. Now let's take this and we will write down here 5,176, and let's convert this decimal number into a decimal number using the same rules that we used converting to decimal. Let's do that, all right? So if we're converting a number into another number system, we divide by the base of that system. So we divided by base 2 to get binary. To get decimal, what do? Base 10. So 5,176 divided by 10 is equal to 517.6. And you remember, dividing by 10, you simply move the decimal point a place. Great. So our remainder, you may see a pattern, our remainder here is 6. And remember what we did after getting our remainder is we eradicated the number after the decimal point. We don't need that anymore. So the next number we divide is 517. This 6 is gone. And we'll divide that by 10. Great. What is that? Well, I'm sure you'll know. It's 51.7. So that's a remainder of 7. Interesting. Can you see where I'm going with this? Eradicate the 7. We have 51 divided by 10 equals 5.1, a remainder of 1. And lastly, 5 divided by 10. And you remember what to do here? Decimal point here. Move it around. You have 0.5 is the answer, remainder of 5. So we have 5176. We have it here. Can you see what we did? We started with the least significant number, the least significant bit, which is the top here, and we drew it out. We drew it out of the number by dividing by the base, and that's the leftover bit, okay? So our leftover, when we divide 5,176 by base, by how many is in each column, like that, divide that by 10, 517.6, remainder 6. So we did that, and then we did it again, and we did it again, and we did it again. And so the most significant number down the bottom here is 5, and the least significant is there. We look in this direction, so what do we get? We get 5,176 in base 10 is equal to itself. Hooray! It's equal to itself. Who would have thought? But seriously, this is why it makes sense. You're dividing the number by how many is in the column, how many can fit, and that will be the number that you're given. Fantastic. All right? I hope this helps you. I hope this helps you understand. And look, you can use the division method to do other things. You can use the division method to convert into hexadecimal. And if you're only learning how to convert to binary now, this is probably coming up next for you in the computer science curriculum or the math curriculum, whatever you're doing. And this is the scary one. This is base 16. This has letters in the last few numbers instead of numbers. And we have octal, which is base 8. Fantastic. And we can do the same thing that we did here, except divide by 8 instead. It's a little bit more complicated though, because the decimal you get is not going to be a nice, neat 0.5 or 0 like we got here. So I'll quickly tell you that after you divide by 8, you get a number, blah, 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 and then you get the leftover number, for example, 875. Then you have to times that by 16, or by 8, rather, if we're doing an octal. So let's say by 8. And that is your remainder. So times by 8, that is your remainder. And I'll make a video about that further on for people who need that. But essentially, this is how it works. You successfully divide, you divide until you get to 0, and your remainders are the binary number. And you start from the bottom of the page and you go up, and that's how you do it. I hope this helped you. I hope you can see that this is really useful. It's way faster than doing it any other way. I'm a big fan of this method as opposed to other methods. I hope you enjoyed the video. See you later.